Okay, so let's get started. You guys can hear me, right? Okay, let me unmute myself. Okay, so we have 40 students joining online. Let's say hi to them, I guess. You guys can hear us, right? Can I get the signal? Okay, great. Okay, so, sorry. I have to put this one. Okay, so let's get started. So I'm very excited seeing all of you guys. So last time I was standing here, it was 2019, and finally I see students again. So in the next 3 months, we are going to actually learn something really amazing together. And that is something that's called a database. A database, as you are going to see, actually a software system that actually manages your data. So we are going to have two concepts, right? So we are going to look into that in this whole semester. There's the concept called the database, which is actually the collection of the data you want to manage. And then there's the database management system. That is a piece of software that manages your database. So this is the two concepts we are going to look into in this semester. So the reason we are so excited about this concept is if you look at today's digital applications, every single one of you are actually interacting with tens or hundreds or maybe thousands of databases every single day. It's really everywhere. For example, if you open some of the app on your cell phone, if you go to your bank, withdraw some money or put some money in, right? You are interacting with some database system, right? You have the vaccination system, right? So the appointment, you are interacting with some type of database system. It really powers almost every single data-intensive digital applications that we have today. So in this course, we are going to actually learn about two things. We are going to learn about how to use a database system. You have a lot of data, and then you want to get insight from your data, and how to use a database system as a user. And then the second thing we are going to look into is how does a very simple database management system could work. If you are going to build a database system, not only to use it, but to build the management system, how would you do that? In the next 3 months, this is going to be the things that we are going to look at together. So this is the first lecture. We are going to spend maybe 10 minutes to talk about logistics and some high-level information about this course. And then we are going to look at one example in real world to really understand what do we mean by data and what do we want from data and what do we mean by manage data. And then we are going to go a little bit deeper to think about what would be an ideal database system or database management system look like. And then we are going to talk a little bit about the history of database management system. So compare with all the other lectures that we have in this course, this is pretty much a really high-level one, right? So if you cannot follow every single detail, it's fine, right? Most of those concepts will become really clear after you finish, like this semester. Okay, so let's talk about logistics. So all the information that we have is going to be on this website, right? So, and I think most of you already have access to it, right? So I sent an email yesterday about the website, right? So what we are going to do is for all the lectures, we are going to actually put them as one item in the list on the website, right? If you click it, right, you are going to see the slides, you are going to see the chapter of the textbook that we are covering, right? Sometimes we have some additional material that won't find in the textbook, it will be there, okay? So all the information will be on the website. So the format of this course is we have lectures Wednesday and Friday. So we will take a hybrid format. So we have the in-person one, which is in this classroom, like here, right? So you are in the right place, I hope. There's the online version, right? So I sent out a Zoom link yesterday via email, right? You can also join online. The lecture will be recorded, right? So we will put the recording up on YouTube, and we will send a link after it is available to all of you guys. We also have exercise session. It will be starting the third week after we learn a little bit about what we are talking about. Then we start to exercise. So it will be Thursday or Friday, right? So you guys are going to form two kind of partitions, right? So exercises are not graded, right? So in terms of evaluation, this course will be 100% the final exam. But it's still very important to attend the exercise session, right? Do the exercise on Moodle all by yourself. So the reason is that we will also do exam on Moodle. And one thing we are going to make sure is the exercise. Yeah, so I think there's some question on Zoom, right? Oh, yeah, maybe just forget to mute. Okay. So yeah, so exercise will be using the same platform on Moodle, right? So it have similar style compared with the exam. So it's very important for you to attend the exercise session, and more importantly, do the exercise by yourself before the exercise session, okay? So, and in terms of exam, it will be very similar in terms of style, kind of scope, and the difficulties level compared with previous years, right? So all those exams of previous year are already available, right? So this is actually how we do evaluation. So we are here to help you to learn, right? So it's a very important course. We want to make sure every single one of you enjoy the course and learn something about database after it, right? So I have office hours. So what we are going to do is I will stay on the Zoom session after Friday's lecture, okay? So we cannot use this longer than our allocated slot, but I will be on Zoom on Friday. If you have any questions about this course, you can just join the Zoom session and you can ask, okay? So what we have done in the last, actually 3 or 4 years, is during the break, during the summer break, I will have some kind of monthly office hour to make sure you can also ask questions when you are preparing for your exam. So we'll continue to do that this year. So this is the office hour we have. All the question answering, you can do that on Moodle, right? If you have any question about this course, just post something on Moodle. Our TA will answer them. So if you have any other questions, right, just send me an email. I'll send our TA emails, right? So we are here to make sure that you enjoy this course and you can actually learn something, right? Yeah, and also if you want to talk about other things, right, so feel free to drop me emails. If you want to talk about research, also let me know, right? I know a little bit about database system. I know a little bit more about machine learning systems, right? But always happy to talk to all of you guys, yeah, to see essentially how we can help. So one thing to succeed in this course is really try to take an active role, right? Given the size of this course, we probably will not have that many interactions during lecture, but please ask questions. Whatever you are not clear, right? So please ask questions. For people who are joining online, right? Just type your question in the chat window. I will try my best to keep track of it, right? If you are here, just raise your hand, right? So, and don't afraid asking questions, right? So if you look at most of the recording that we have in previous years, you see, I mean, sometimes the QA lasts like 1 hour, right? So just ask questions, don't be shy at asking them, right? So again, right? So during the summer break, we also have some office hours, right? So if you have some questions that we didn't answer during the semester, don't worry, you will have time, chance to ask about it. Yeah, again, if you have any suggestions about how we could run this course better, right? So just let us know, right? So we still continue to improve this course. And if you look at the course this year, I hope it's much better than what we have last year, right? So this year is the first time we run this hybrid thing. I'm sure there are a lot of things we can do better, right? Any suggestion you guys have, just let me know. So there's a question online that is, will the lecture be recorded and made available online? Yes, yeah. So I will send out the link of the recording after every single lecture. Will the exercise session be recorded and streamed? It will be recorded. It will it will be streamed in the sense that there will be a Zoom session, right, that you can join and ask questions, have more interactions, right? Any questions from the local audience? No? Okay, great. So textbook, right? So we will focus on the English one, right? So database system complete book, Stanford book. There's a kind of a German textbook which is kind of similar to this one, right? You can use either of those. But when we write kind of textbook chapter on the web page, we will take the English one. Sometimes we are going to take some of the material from this book called Foundation of Databases. You do not need to read it, so it's a theory book, right? If you really want to go deep into the theory of database system, right? So that's a really fun book to read, right? So, but again, like we are not going to take material from this theory book and put in the exam, right? But sometimes we try to kind of put some theory into the lecture, and sometimes interesting for you to read it and understand the theoretical foundation of database system. So database is a very mature topic, right? So there are actually a lot of good online resources, right, to help you learn, right? So there's a database course from CMU, there's a database course from Berkeley, from Stanford, they're all online, right? So if you want to learn kind of some of the aspect of database system a little bit deeper, right? So sometimes you can find some additional material in these online resources, and sometimes it's just really fun to look at. So here's how to think about these different kind of resources, right? So there's always two dimensions. If you take a database course, there are always two dimensions. The first dimension is how to use a database as a user, how to write a SQL query, all the type of things. There's another dimension about how to build a database system, how does the kernel actually works, right? If you look at the courses, right, so they're actually in different points in this space. Some of the courses talk more about how to use a database. Some of the courses talk about how to build a database system. So our course will be somewhere in the middle, okay? So we will actually try to cover as much as we can, but we are kind of in the middle, kind of balance between these two dimensions. We will have a little bit more theory, little bit more, sometimes talk about machine learning, right? So, but if you have some topic to say, yeah, I'm very, very interested in this topic, I want to learn more, right? Sometimes you can find more material in those online resources. Okay, so this is about logistics. Now let's start to think about the technical content of this course. So let's try to motivate why do we need a database? Why do we need a database management system? And what do we even mean by managing the data? And why is that useful, right? So let's try to take one real-world application and think about what data do we want in building such application, and what operations that we want to run over my data to build such application. So let's take this thing. Let's take this vaccination appointment website and think about if you want to build that website, right? What do you need, and how can we do that? Now, again, this is a very kind of complex system. So let's take a SAP process in the website. So whenever you want to book kind of your make appointment, right? You pick a clinic, and then it's going to show, yeah, you can make, for example, here, 2 empty slots that you can make appointments on. You click this button, right? So it's going to show you, yeah, this is all the available appointment we have in this clinic. You pick one of them, right? That's going to say, yeah, so now you make an appointment for your first slot. Then you can make the appointment of your second slot. So let's think about this application and think about if we want to build such an application, what do we need? So to build such a thing, right, we need to have some knowledge, some information about, multiple things, right? We need to know, a whole bunch of users, each user corresponding to someone who can be vaccinated in this country, right? And for each user, you kind of know some information. You have the ID of the user, right, to make sure when you log in, they pull out your information, not other people's information. There's the address of the user, right? So there's a phone number of the user, right, to make sure, for example, when the booster is available, they are going to send you a text message, right? So all those information about the user, you need to put them somewhere, right? And then there are the information about all those clinics who can give shots, right? So for each of the clinic, there's a whole bunch of information that you need to have. For example, the name of the clinic, the address of the clinic, and also the capacity of the clinic, right? Some of them are larger, some of them are smaller, right? So some of them can give more shots per day, all those type of things, right? So all of those are information and knowledge that you have. And you also need to know the association between these different things, right? For example, when someone make an appointment, what do you have? Essentially, you have a collection of tuples, right? You know this user already make appointment at this clinic on that day, right? It's a kind of a triple, right? You have a whole bunch of those. The collection of those triples are the knowledge that you have about this application. That's all the appointments that's already in the system. You need to store them somewhere. And sometimes triple, even they look very similar, they have different meanings, right? For example, you could have a whole bunch of information about whether some user actually, some patient actually show up or not, whether the vaccine is being, like whether they already take that or not, right? So again, you can have this user, this clinic on that day, right? You give that person a shot. These are all the informations, all the knowledge that you have about this application. So to build such one application, to build that website, right? So there are two different dimensions, right? So let's not worry about how we are going to store this data, how we are going to manipulate those knowledge. Try to imagine at this moment, all the things you know about this application are being written in a very thick book in library that you can just read them, okay? So what do we need? So assuming you want to build the first thing, given a clinic, how can I find out how many essentially appointments potentially I could make? To enable that, you have something you want to do, right? And then you have some insight that you want to get from all the knowledge you have. So here, for example, I want to know, giving a user A, right? How many appointments can this user actually make? This is something you want to know, right? Given all the facts you have about this application. So how to answer that? Well, if I know all the knowledge on the left-hand side, right? For example, I can go through all the collection of appointments that user A already make, right? I know one person can only make 2 appointments, right? If this person haven't made any appointment yet, right? The answer I'm going to give you is going to be 2, right? And then you can visualize it, right? You can visualize it on the website, right? But the point is, once you have the thing that you want to know, your question you want to ask, you can use your data to answer that question and get the answer. The answer is going to be the insight you have out of your data, okay? And there are potentially other things you can ask, right? For example, if you look at the second view, right? So what are the things you need? You need to know, okay, how many slots does this clinic actually available on a certain day, right? This is one question you want to ask. So how can you do that? Assuming I have all those information and knowledge, I'm going to look at, for this clinic, I know the capacity of this clinic, I know all the available slots, and then I go through all the appointments that I have, the different users have at this clinic on that day, and then I can give you a whole bunch of available slots that you can make appointment on in this clinic, and then can visualize it. Right? So visualization is always another function once you have the insight. But again, you have information, you have knowledge, and then you have the things that you need to know, and then you get your insight out of it. So, and sometimes, for example, if you click this button, right, you say, I'm going to select this slot. I want to make the appointment on the slot. So what you are going to do is not always ask questions. Sometimes you also get more information, more knowledge coming from the world. For example, when a user clicks this button, essentially what you're going to say is, okay, now I have more knowledge about this application now, because I know someone already made one appointment. So another thing that you want to do to build such an application is really have the functionality to enrich your knowledge, right? Whenever someone make an appointment, you know a little bit more about this application, right? Here you can actually put in this red tuple, right, inside your knowledge base, your pool of knowledge, right? So that could be another thing you could do. You can manipulate your knowledge, you can enrich your knowledge. And sometimes you can do analytics, right? Sometimes you can say, yeah, some scientists are very interested in, for example, what is the vaccination rate of people older than a certain age, for example. What are you going to do? This is something you want to know about your application. What you can do is, yeah, I take all the patients, I filter them by age, right? And for every single one of them, I see how many of them are already vaccinated, and then I can get an answer to this question. And sometimes you can build something more predictive, right? For example, if you give me the information of some new user, right, not in the system, yeah, can we predict whether this user is going to be vaccinated or not? Well, that's another thing you want to know, given the information you have about this application on the left-hand side. Well, what are you going to do? You're going to find a similar user, for example, right? And they're going to see whether that user is vaccinated or not, and use that as one way to make those predictions. If you look at this, we can already see some patterns. On the left-hand side, you have information, you have knowledge about this application. In the middle, there are things that you want to know, and there are things that you want to do. And given the things you want to know, on the right-hand side, you have your insight. And in this course, the goal of the database system, data management system, is to make it as easy as possible for you to extract insight from your data. So let's talk at a little bit more abstract way. So still, we have knowledge, we have things we want to do, and we have insight. How do we think about this? How do we think about our data? What is this data, right? So in this course, we are going to think about all those data that we have being stored inside a database. And we are going to think about them as a collection of facts that you know that are true. Okay? This is a collection of facts that's inside my database. We are going to define that on Friday about what do we mean by facts. Okay? And then there are a whole bunch of things that you can do over this collection of facts. You can do logical reasoning, right? You can have some logical rule to say, yeah, I want to do inference in a mathematical logical way, right? I want to take as input this collection of facts and produce new facts that I can prove given this collection of existing facts. That's something you can do, right? One example is, yeah, how many appointments can this user make, right? Yeah, so you can actually prove, yes, under this kind of logical construction, right, outputs need to be 2, right? And then you can do other type of reasoning. You can do statistical reasoning, right? It's not producing new facts, but producing statistical correlations, producing predictions, right, that's going to hold statistically, right? For example, give me a new user, how can we predict whether this user is going to be vaccinated or not, right? That's not a fact. That's our prediction about the future. That's something you can do given this collection of facts. You can update it, you can enrich it, right? You can put a new fact into a database system. So this is actually, at a higher level, what we are going to deal with. So specifically for this course, we are not going to talk about all the possible ways you can manipulate your data. It's very important that you know there are other ways beyond this course for you to manipulate your data, for you to query your data. But in this course, we are going to talk about something really specific. We are going to think about our database as a collection of facts. We are going to talk about the logical reasoning step, that I have some logical construction. I want to produce new facts given my existing collection of facts in the database. And we are going to talk about how to manipulate this collection of facts, how to delete facts, how to add facts, right? How to enrich this collection. So this is what we are going to talk about for this whole course. We are going to spend 3 months on it. So it's very important for you to know this is not the only dimension of data management. So this is a very old area. We started half a century ago, right? And I hope we are going to continue in the next half a century. So there are a lot of things you can twist for you to have a new type of data management system that we are not going to cover in this course. But it's very important for you to know, right? So sometimes you can have a different view about what is data. Here we think about data as collection of facts, but you can think about data as something else, right? Whenever you twist how do you think about your data, we are going to call that data model, right? What is the model of your data? Once you twist that, you are going to have a different type of database management system. That's very different from what you see in this whole course. But it's very important for you to know that they actually exist, okay? And sometimes you can change the things that you want to know, right? For example, instead of doing those logical reasoning, right, I want to do statistical reasoning. I want to learn a machine learning model out of this collection of facts to help me to make predictions, right? In this case, you are going to have a very different type of system. If you want to learn more about that, next semester we actually have a machine learning system seminar. Talk about, how that system going to change if the things you want to do is not logical reasoning, but more statistical reasoning. It's important for you to know that you can do so many different things over this collection of data, okay? So this is what we are going to kind of learn about in this semester. So once you take this kind of little bit higher level view, right, it's kind of not that hard to get a structure of the remaining collection of lectures. What are we going to talk about, right? So they're actually pretty natural. So first thing is, how to represent and how to organize this collection of facts, right? So that's something we are going to learn. So the first chunk of thing we are going to learn is called the data model. So as you are going to see, we are going to think about this collection of facts and model them as relations, okay? Which is a collection of tuples, like a table, right? So that is something that we are going to think about, like about data model. And we are going to talk about, how to organize those relations and to map this collection of facts to those relations. Because there are so many different ways you can organize your information, even if you think them as a collection of facts. This is something we call database design theory, for example, normal form, something like that we are going to talk about, I think, towards the second half of the course. Another thing, right, so very naturally that we need to discuss is how can I describe the things that I want to know, right? I want to do logical reasoning. There are things I want to know out of my data. I want to update my data, right? How can I represent the things I want to know in a way that the machine can understand? This is something that we call query language. And we are going to talk a whole bunch of those. So those more theoretical ones, like relational algebra, to a kind of more practical one, like writing SQL queries. But whatever it is, they are query languages to describe the thing that you want. And then, of course, once you know your data, you have a data model, you have a query language, right? We need to run them, right? We need to run this query over my data and to get an answer, right? So here we are going to spend actually 50% of this course to talk about how to do that efficiently. Giving a database, giving a query, how can you really run it to get insight? So here our goal is to deal with terabytes of facts, right? Really big database. And also when you have a couple thousand or couple millions of concurrent query, how can you deal with that? If you look at this, this is a full chunk of things we are going to talk about in this semester. We are going to talk about data model, how can we think about data? We are going to talk about database design theory, how can we kind of organize kind of my facts? How can we are going to talk about query languages. We are going to talk about the execution of the query over my data. So this is pretty much what we are going to cover for this semester. So now given this application, right? So let's go to our first definition. What is database and what is database management system, right? So a database is a collection of data or facts, okay? That's your database. For example, you have, if you are running a bank, right, you have the information of all the bank accounts. They will form a database. You have your data on Facebook, on Amazon, right? So that's another database. A database is a collection of data or facts. A database management system is a piece of software designed to really try to maintain and utilize a large collection of data. Okay? So let's look at more example. Right? Assuming you are building Wikipedia, right? What data and information you have, right? You have this content of each article that are going to be stored inside your database. You have the history, right, of every single article inside your database. You have the information of each user, for example. And when you visit Wikipedia, there are things that you need to know to build such a website, right? You need to be able to select a subset of those information, right? Present that to you as a web page, like what we show on the left-hand side, right? So here we are going to talk about like 50 million pages. So you need to do that really efficiently, right? So and when you edit and contribute to Wikipedia, you also need to save all those information back to your database. You need to be able to update it, right? So another example, for example, look at Flickr, right? So what are the information and data that you have, right? You have all those photos, you have user, you have text, you have comments, right? When you really visit this website, you need to query this collection of data. You need to select a subset of this to show that to you, right? All the picture contain dogs, for example, right? How can you do that? When you have millions of images, sometimes you need to do some recommendation, right? What is the next image I need to see, so on and so forth, right? Once you have data, right, you can actually present those information, right, and also get insight about what is here. So essentially the way we think about the thing that we are going to learn is that you have database, contains your data, you have application that you want to build, and you as a user is in the middle. You try to specify to a magic box, yeah, give me this piece of data. This is what I want from you. This is what I want to know. Database give you an answer that satisfies your requirement, and you can do whatever you want over that answer, right? But what's in the middle is a database management system, and the job is really try to connect the user and the data. Okay? So this is really high level, right? We talk about applications, we talk about definition of database and data management system. If you look at this, right, a database, a collection of facts, a database management system is what to maintain and utilize a large collection of data. There are a lot of questions given these two definitions you can ask to really make your database professor upset. That is okay. So given these definitions, is file system a database? Right? I have my file system. I can open a file, I can update my file. What's the difference between a file system and database system? Right? In the file, I have a collection of data, I can store it, I can manipulate it, I can use it. What's the difference? Is file system a database, given this definition? I have a Python array inside my memory, right? So yeah, it's a piece of data, right? Contain facts. Is that a database management system? So this is actually something that we need to talk more about. That is, a database management system is not a kind of arbitrary piece of software to give you access to data. Actually, we want something a little bit more. We want more property, more functionality from a database management system instead of, in addition to just getting access to my data. So now let's think a little bit more about all the properties that we want from database management system. And then let's take one concrete application. And this is actually the first database application that I think human ever built back to 1960s. So let's take the application, and let's try to compare different ways that we could do to build such an application with a database or without a database, And then we try to think about what are the properties that we want from a database management system that could really help us. And then let's try to take this application. Right? Here's a video. We'll go back home, try to look at it. But this is about Apollo 11. Okay? This is actually one of the first database applications that human ever built. Right? This is why we have a database in the beginning. So what people want to do back in the 60s is, yeah, they want to build this rocket, which is very complex. So they want to manage, actually, the bills of materials. Essentially, to build a rocket, there are different components, and there are different suppliers of those components. The first database application is actually used to manage all those information. So let's go a little bit concrete. Let's try to build a toy version of this. Let's just try to manage this piece of data. Okay, I want to build this toy. There are different parts, and there are different suppliers of those parts, right? So what data do we have? We have supplier, we have part, and we have which supplier supplies which part, right? These three pieces of information. And assuming we are curious about two queries, there are two things we want to know. The query number one is, yeah, give me all the suppliers for this part. Okay, it's a very simple query, assuming that's one query that we want to ask. The second query is, yeah, find me all the parts that's supplied by a supplier. Okay, so let's think about this very simple data model, very simple piece of data, and these two very simple queries. And let's think about different ways that we can build a system to make this happen. So we can always write Python, write Java, write whatever, like program, use whatever program language that you are familiar with, right? So what if we do this? We create a whole bunch of in-memory array, right? One array kind of store all the suppliers, some store all the parts, some store all the kind of like supply relation between parts and supplier, right? And then whenever you have new data, you load them, okay? You just append to this array whenever you have a new piece of information. Whenever you want to answer queries, what would you do? Yeah, I mean, you guys know how to program, right? Yeah, for example, for query number one, you go through all the possible supplies relation, right? And yeah, if the supplier satisfies your condition, yeah, I mean, you return them. This could be one way to write down query number one. Yeah, similarly for query number two, you can do something similar, right? You go through all the suppliers, right? If that satisfies your condition, yeah, you go ahead, you go through all the supplies kind of relation. If the supplier matches, you go ahead, you return all the parts. This is kind of a very simple way for you to store the data, for you to answer those two queries. So what's the problem of building this? If you kind of go to NASA and say, yeah, this is the database I built for you, potentially what could be the problem? The first problem is, yeah, I mean, whenever you reboot the machine, everything gets lost, right? Whenever your roommate gets trapped on the wire, and yeah, your data is gone, right? Because all your data here are actually stored inside memory, right? So yeah, that's something probably we do not want for this NASA application. So the second thing about this is that it actually cannot handle the cases where your data is bigger than the memory, right? Right now, you have your laptop, yeah, they have 32 gigabytes, right? So that is not that big. If you are building a kind of a big database, sometimes you have a terabyte of data, right? They're clearly bigger than your memory, and you cannot handle that in this way, right? By storing everything inside memory. So that's a problem, the potential problem I could have. And there are actually many more, right? Think about what could be the thing that you do not want by building it this way, right? For example, if you look at the implementation of query number two, yeah, that might not be optimal, right? There are a whole bunch of nested for loop, and it could be very slow. There's a whole bunch of problems that you have in managing your data in this very simple but natural way. Can we do better, right? Yeah, you could do better, right? You guys know what the memory map file is, right? You can store all the information on your hard drive, right? Whenever you want to read it, you open a file, you read it. Whenever you want to update it, yeah, you update the file. So this could give you something even better, right? But again, there could be problems when you are really managing your data in this way. So let's think about that. What could be the problem? I store all my information in files. Yeah, I read and write the file in this very simple way. Well, first one, like now data is on disk. Great, right? When you reboot the machine, yeah, data will still be there. Amazing, right? That's some improvement. But there's still problems. First one is, once you change your data format, for example, you write a piece of code assuming some of the data layout, and later you want to change your data layout. For example, there is some additional attribute of the supplier you want to add. Yeah, you kind of need to change the whole piece of code, right? Because when you are parsing and storing your data in this way, your code has some assumption of what the data is actually look like. Which attribute is stored before which attribute. If you want to swap the order, you kind of need to change your code, right? So that's not something we want. Ideally, we want to make sure that even if you add some information, you change your data, your piece of code still remain the same. That's the ideal case, right? So that could be something that we don't like about this natural implementation. So another thing about performance, right? When you store your information on your hard drive, it's actually much, much slower to read data from your hard drive to your CPU, right? So if you are not being careful, the performance of your query could be very, very slow, right? There are a lot of things that you need to do to make that fast. And also, what if you have concurrent access, right? You store your data inside your file system. Now you have two different users asking different queries. That happens a lot, right? So you are running a database for your bank. Yeah, there are different people at different places try to withdraw money, right? How can you deal with that, right? And how can you deal with recovery, right? When you are in the middle of updating your file, right? Someone reboots the machine. When you restart, how can you make sure your data is still correct? How can you recover from failure? So all those things are something that we need to be really careful about. And clearly from this very natural implementation, you are not able to get that. Of course, you can build everything from scratch. You guys are very smart. I'm sure if you spend a couple months, you can have some implementation to fix all those problems. I'm very confident. But the thing that we want to understand is, can we build some basic infrastructure to manage data such that you can simply ask a query and that piece of software deal with all those problems automatically for you? And that is our goal. And that is what we want from a database management system. So essentially, the goal of this course is try to understand database management system that actually try to solve those problems that we see in these two really naive, and not that naive, but natural and simple implementations. So essentially, after this semester, if you are facing this application, I hope what we are going to do is not to write a piece of code that looks like this. Is you are going to write a piece of code that's actually going to take all those problems that we see in this piece of code and to use a database management system, right? So let's try to define a little bit more about the property that we want, okay? From the problem we see here to the ideal, to the problem we see here to the property we want from a database management system. Okay, so the problem we have with this piece of code is the code needs to change once your data format change. That's not something we want. So the property we want from a database management system is something that we call data independence, okay? Which means that your application who are asking queries shouldn't have any information of how the data are being stored. Because you don't have that piece of information, the moment you change your data format, your application do not need to change. This is one property that we want. We are going to work really hard to make that happen, as you will see. So second problem is about performance, right? So how can we optimize the query, make that fast when my data is on hard drive? So here, what the property we want from a database management system is something we call declarative efficient data access. Essentially, the system should be able to store and retrieve the data efficiently without the user worry about it. Ideally, the property we want to enable is you give me a query to say, this is what I want from my database. And database automatically try to search the best possible way to get that data for you without you optimizing the performance of that query. This is something that we want. There are other things we want, but let's take a break and in 15 minutes, and let's get back and continue. Yeah. Okay, great. So yeah, we were talking about the property that we want from database management systems, right? So we take this very simple implementation in Python as inspiration, and we think about what are the problems there, and what are the properties that we want from database that we don't have such a problem. So the first thing is we hope that our code doesn't need to change when you change your data format. When you add a column, when you add some attribute, I hope my code will not change, right? So that's something that I hope can happen. And that is some property that we call data independence, right? We want to make sure your query, your application doesn't know how the data are being stored or how the data are being organized. And second thing is we want the performance to be good. That is, when you give me a query, right, so I want to make sure you as a user who are interacting with the database doesn't need to worry too much. As we will see in this course, you still need to worry a little bit, but doesn't worry too much about how to optimize for the performance. We want to make sure that you give me a query. Now, I'm a database system. You give me a query, and I try to automatically optimize the implementation of your query over my data. That is something we want to enable. So about concurrent access and crash recovery, right? So we want to have what we call transactional access. That is, even if there are multiple users asking queries, updating my data at the same time, what I want from a database management system is as if all those requests come in a sequential way, right? I want to make sure I manage all those concurrent access in this way to give you this notion of guarantee of concurrent access, okay? We want to make sure the whole access is transactional, and we want to make sure when you have some failure in your system, like the system crashes in the middle, when you reboot your system, I can recover, right, from the failure. That's another thing that we kind of want to enable inside this database system. And then we want a generic abstraction, right? You have so many different ways to write your query, and there are so many different queries that you want to ask. We want to make sure we have a generic abstraction that you can specify different type of queries using that same abstraction. So this is the 4 properties that we really want to enable inside the database systems. And the goal of building a database system is if you as a user are using the database system to manipulate your data, you get these 4 properties. So that's the contract we want to provide for our user. So hopefully, after this course, when you are facing this application, right, you are going to write something that looks like this. You are going to declare the type of data you want to manipulate, right? I mean, you want to create, yeah, I have a whole bunch of suppliers, I have a whole bunch of parts, whole bunch of supplies. I don't tell you how you should store them. I tell you this is what my data looks like. And then whenever you are manipulating data, you are manipulating them in a high-level way. You are not to say, yeah, my data is a Python dictionary, look like this. That's not your job to worry about as a user. You tell the system, okay, here's one supplier with this amount of attributes, put that into my table, right? So that's something that you are able to do inside today's relational database system. You can manipulate your data in a high-level way. Whenever you are writing query, you are not telling the database how to get the query done. It's like you do a for loop here, do a for loop that. That's not how we talk to a database. The moment you talk to a database in that low-level way, there's nothing the system can help you, okay? And it cannot optimize that for you. So you are going to query the database in a high-level way. You say, yeah, I want to get information from the supplies and the parts relation, right? So this is the condition I want you to satisfy in your answer. You are going to query your data in this high-level way. So after this whole course, right? So hopefully, you are going to do the thing on the right-hand side to manipulate your data instead of the thing on the left-hand side. The difference between the left-hand side and the right-hand side, even though they have a similar length of code, is whenever you do the whole thing, like on the right-hand side, you get that full properties for free coming from your database system. So yeah, so once you have database, right? So the key difference is you are going to tell the system what you want instead of how the database is going to get that for you, okay? So essentially, you are going to interact with the system in a declarative way, not an imperative way. And that is the key difference. And that is what you want to build. And the contract between the system and user is as long as you are doing this, I give you all these good properties that you want in your application. So this is the good thing about database, right? But now let's try to do a little bit of critical thinking to say, yeah, do we have these advantages of using a database? Can bad things happen when you're using a database system? Are there applications that I do not want to use a database, right? So we are not going to spend too much time on this because that's not the goal of this course. But they actually are considerations that in practice that maybe sometimes you do not want to use the amazing database we are going to learn in this semester. Let's just use one slide to actually talk about those kind of cases. What could be the potential downside when you are using a database system that can provide you so many different amazing properties? Well, often when you have a mismatch between what you want and also what the database provides, and that is actually some cases in the special consideration to say, yeah, do I really need a database for that? For example, in some of the applications, you actually do not need all those guarantees. Because when database give you those guarantees, it's actually not free. It's actually going to have some performance overhead to make them happen, right? When there's a mismatch between what you really need from your application and what a database can provide for you, and that could potentially be scenarios that just using a database might not be the ideal way of doing that, okay? When you find a job and when you really try to build applications, right, think about that. Whether there's a mismatch between what you really want and what the database guarantee you that it can provide, right? Sometimes you don't have a strong kind of concurrent transactional requirement. Sometimes you are building something with only a single user access it. You know that for sure. In that case, you might not need all those transactional guarantee coming from your database. Sometimes you are managing, for example, like a graph, but your database says, yeah, I'm managing everything as a table, right? There's all those mismatch between what the database try to guarantee and try to support and what you need from your application. When that happens, that is the time to think about, yeah, whether I really need that or not. So sometimes there's a data model mismatch, sometimes there's a query language mismatch, right? Try to think about them carefully when you are building real applications. So the consequence of this is people have been focusing on different applications and different scenarios, and they will actually use different type of database systems. Some of them give you a weaker guarantee on some aspect, some of them give you a different data model, so on and so forth. That is why if you look at today's data landscape, you can see there's a whole bunch of database systems, right? If you think, yeah, why do we need 100 different database systems? It's because they are all optimizing for different scenarios. Out of that 4 different properties, there's a whole bunch different level of support, different level of guarantees you can get from your database system. And that's actually give you this whole landscape of these hundreds of different data systems that you can use today. So we are going to actually pick one point in that space to talk in this course. That is, for all the 4 properties, we want to give you the strongest guarantee. Okay? But that's not the only choice you can make. Okay? The hope is after you finish this course, you know how to think about the database system, right? You say, yeah, I want to give you these 4 properties. This is how I would build a database system. And in the future, when you really build a real application all by yourself, try to think about what type of guarantee you really want and try to pick the right data system for you, for your application. Okay, so this is our wish list. There's 4 properties. In this course, we are going to talk about 2 things. That is how to take advantage of these amazing properties as a user, how to use a database system, and also how can we enable those 4 different properties when we are building a database management system. This is something we are going to spend our next 3 months studying. Okay, so now we understand, we look through one real-world applications, understand what is data, understand what we want to do, like Earth data. We kind of think a little bit about, yeah, what do we want from a database management system, all those 4 great properties. Now, in the last part of today's lecture, we are going to talk a little bit about the history of database management systems. So we are going to talk at a little bit really a higher level, right? Because we only have 30 minutes to talk about something that happened in the last half a century. If you don't understand every single thing, right, in today's lecture, it's fun. I will promise you, after 2 months, when you go back and look at this lecture, which will be recorded, right? So you are going to see many of those concepts start to come together and start to make sense, okay? So now let's talk about history. Why do we talk about history? The reason is, if you look at that 4 properties we want to enable inside database system, it's actually surprisingly hard to actually enable. And people spend a whole bunch of time and a whole bunch of trial and error in trying to understand that 4 properties. By looking at the history, you see the struggle that this community have in enable all those properties. So in the very, very beginning, back in the 60s, right? So there's something called hierarchical model. And this is actually what the first database system look like. And we are going to see what is their data model, what is their query model, right? And whether they satisfy that 4 properties or not. So in the very beginning, there's a hierarchical model, right? So there's a system called the IBM IMS. The first version is 1968, and actually still running today, which is fascinating if you think about it. So it enabled the Apollo 11 database that we talk about, right? And actually running a lot of transactions today, right? Every single day, I think this is from IBM, there's kind of 200 billion transactions still running at IMS, a system that started in 1968. So highly likely, if you go to a bank, go to an ATM machine, when you withdraw some money, highly likely you are triggering some of the IMS transactions. So let's talk about how that works. What are the advantages of a hierarchical model, and what are the limitations? So the data model here is, I think about my data as a collection of records. Okay? So I have a whole bunch of records. Each one of them is associated with a record type. For example, I have my supplier, and I have part. Okay? And then there's a whole bunch of instances, right? In the sense that my record type supplier contains a collection of, record, right? So here is a tuple, the ID equals 0, name equals to ABB, country equals to Switzerland, right? So that is one tuple, right? That's one instance of this record type called supplier. So my database contains a whole bunch of those. And I have a database schema to tell you how my data looks like. It's actually a hierarchy of those record types. That's why it's called a hierarchical model. Okay? So, for example, you have two record type. You have a whole bunch of supplier, and you have a whole bunch of part. There are two record types. And then you have a hierarchy among them. So here you have supplier point to type. Okay? So this is a database schema. And then a database instance, how you organize your data, is a hierarchy of instances that is consistent with your database schema. For example, you have, one supplier, ABB, right? So which is of the type supplier, okay? And then this supplier supply multiple parts. Part 1, part 2, right? So you have this instance ABB point to part 1 and also point to part 2. Okay? So the whole thing forms a hierarchy. When you have another supplier, you have another record instance, right, on the top, right? Sometimes you can have this different part point to different parts, right? You have this subparts, right? So you can have all of this. So in hierarchical model, this is what your database looks like. It's a hierarchy among a whole bunch of instances. This is how the system models the data. Okay, this is the data model of this type of system. So how can you query it, right? If we want to know something out of the database, how can we query it? The query language provided by IMS, at least back in the 60s, is it has a query language that's a record at a time. You actually specify which record you want, okay? And then essentially, you try to traverse the tree, okay? That is because your data are stored in this hierarchy, right? And you try to move your cursor around the tree. That is how IMS think about the query language. So for example, you have some command to say, yeah, give me one record, give me the next record, because it's a tree, right? And give me the next record within this parent, right? It gives you a whole bunch of things for you to move your cursor around the tree. And that's how IMS, or hierarchical model, at least back in the 60s, think about how to write your query. Okay? So let's look at one example, right? So let's say, yeah, so I want to find all the parts supplied by the supplier B, right? How would you do that? So in IMS, right, so the thing you can do is, yeah, so you have something like this. In the first line, right, so what you are going to have, right, is you get a unique supplier. What it's trying to do is try to identify some of the root node. Say, yeah, find me this. And then you try to do this. Essentially, you try to say, yeah, get me the next within this parents. I try to enumerate all the children of this node. And for each one of them, yeah, I try to see whether that satisfies my condition. If it satisfies, I return it. Otherwise, I do not return it. Right? And you continue this. As you can see, when you are writing a query language in this hierarchical model, you have some underlying assumption of how the data are being organized. That is, within every single supplier, if you go to the child node, it's always a part, right? And then your query is actually trying to tell you, if you want to get me the thing that I want to know, you do this. You find the supplier, you enumerate all the child, that's what you do, and then you can get me the answer. So, for example, if you want to say, yeah, give me all the suppliers for a certain part, what would you do? And this one actually goes to the first limitation of hierarchical model. That is, it's actually very hard to do, right? Because once you have this hierarchy, that is, my parent is supplier, my child is part, it's very easy for you to go top-down to write a query like that. But it's very hard for you to go back, right? So that's actually something surprisingly hard to do inside a hierarchical model. And that goes to actually the first limitation of this type of ways of modeling your data. So, and how can you write this second query, right? So a natural way is for you to actually change your data format, change your schema. If I have a database where I have the part as parent and supplier as child, yeah, it can be very easy to write the second query, but on the other hand, it's going to be very difficult to write the first query, right? So that's actually something we don't really like about the hierarchical model. So now let's take this data model, the query model, and also the execution model, and try to think about that 4 different properties that we found from database system, and try to see whether hierarchical model really gave us that. So let's look at data independence, right? The application shouldn't know how data are organized. In hierarchical model, this is something really hard to enable. Why? Because in your query language, when you are writing the query, you are actually using the information of how the data are stored or how the data are organized. You know which type is the parent and which type is the child. And when you specify how to move your cursor around the tree, you are using the information of how the data are organized. So it's very hard for you to enable data independence when you are taking a hierarchical view of your data. So another thing is when your data are not really a tree, you actually end up doing something kind of ad hoc. Okay? So assuming, for example, you have a database that looks like this, that you have like one part, like part 1, being supplied by 2 different suppliers, right? In this case, you don't have hierarchy, right? So you end up have a whole bunch of those kind of replicas of your data, right? Which you need to deal with when you are writing a query, right? So this is another thing that's a little bit hard to do when you have a hierarchical model, right? So again, it's very hard for you to have these type of things. When you are writing a query, right? Depending on how your data are organized, the same query either runs here and doesn't run here, right? This is what we mean by this model, I mean, at least back in the 60s, doesn't really give you good support of data independence. So let's talk about this performance thing, right? Given a query, how much do I need to worry about the performance of that query? So this is actually another thing that the hierarchical model are not that ideal in terms of providing you this property. So assuming I have a database look like this, I have supplier point to part in my database, and then I try to write this query, right? Try to find me all the right parts supplied by the supplier B. Yeah, we can write this. We can write the first query. I go to supplier, and then I kind of enumerate all the child node, right? I could do that. But I could implement this in different ways. For example, I could write a query look like this. I just go through all the part and try to identify whether it's right or not. And I know, assuming I have a single supplier, the second query will be actually more efficient than the first one, right? It's probably a more efficient implementation compared with the first one. When you have a lot of suppliers, right? So I know the first one will probably, it's actually correct, second one is actually wrong, right? So, but as a user, right? If you are using a hierarchical model, it is actually your job to think about, okay, this is a query I want to ask. Which one of these 2 implementations that I should do. There are so many different ways I can traverse the tree to get the thing I want. Which is a good way, right? If you are using a hierarchical model given this query language, that's actually your job to figure out what is a good implementation of your query. When you have to do that, right? So we say the database doesn't really give you this type of automatic optimization of your query. You need to worry about performance by yourself. So this is actually one collection of limitations that we have about the hierarchical model, right? So just to recap, right? So you think about the data model like this. You have a whole bunch of record, right? A whole bunch of instance of record. The database is a hierarchy of those records. Your query language is a record at the time you try to traverse the tree, right? The problem of this is it may not have some mismatch of the data, right? So it doesn't give you this data independence, right? It doesn't really give you those automatic optimization of your things, right? So there are applications in which all of those problems are not really problems, okay? So that is why you still see MS being used today. But we're always curious about, given this, whether we can do better. And that's actually what the people have been asking back in the 70s, right? So given this hierarchical model to start with, we know it has a whole bunch of problems. So what should we do? Can we do better? So that's give you the second type of data model called the network model, okay? So it's actually much more flexible compared with the hierarchical model. So it's look like this. So the first implementation is actually in 1969, integrated into the COBOL programming language. Yeah, let's look at how it works, what are the advantages, and what are the limitations. So the data model here is very similar to hierarchical model. I have a whole bunch of record type. I have some supplier, I have part, right? All those type of things. My instance is, yeah, so for each record type, I have a whole bunch of tuples, right? So, and database schema and instance is actually not a tree, not a hierarchy, but a network of types. So, for example, right, so when you want to have supplier, part, and supply, right, you can have 3 different record type. You can have a whole bunch of records for supplier, whole bunch of records for part, and all of them connected to another record type called supplies, okay? So essentially you have this, not a hierarchy, but a network between records. When you have a database, right, you could say, yeah, so I have one supplier, and then I have one part, right? So, and I have supplies relation to have this ABB and part 1 linked to the same thing, right, as a network. And whenever I have different parts, right, so I have a different supplier, different parts, right, so I have this network. Instead of forcing my data to form a hierarchy, now I say, yeah, I can deal with a network. Okay? And then the query language, giving a database look like this, it's still record at the time. Essentially, you try to move your cursor not around the tree, but actually around this network. So it's more flexible than the hierarchical model. So in this case, right, what to how can I do this query, right? Give me all the right parts supplied by the supplier B, right? So yeah, so do something like this. In the first line, right, you say, yeah, give me one supplier that kind of identify one node like in the network, right? And then you say, yeah, and then find me the next supplier record in supplies. You kind of go this, right? And then you try to go this, you try to find the part, right? So you have this query language to actually tell you how you are going to move your cursor around this network. Whenever there is some of the record satisfy your condition, you return them, right? So this is actually much more flexible compared with a hierarchical model, because now I'm able to write a second query, which I cannot write in the hierarchical model, right? So how can you give me all the suppliers for part A, right? It's the same. I identify a part. I try to tell you, yeah, this is how you move your cursor in my network, and this is when you should reply, like when you should return kind of like certain instance. So these two queries are actually very natural to be implemented if you have a network model, which is actually already a huge improvement compared with a hierarchical model. So, but now let's look at these 4 properties that we want. Let's think about data independence, right? Given this data model, that data is a network of tuples, given a query language that actually moves the cursor around this network, do we have data independence? In this case, still no, right? Because whenever you are writing that query, you are assuming you know how the network is being organized. You are telling the database how to move this cursor, which is a function of your data organization. And that is something that we actually really do not want. It's the same problem as a hierarchical model. The moment your data schema start to change, all the applications, all the query you wrote before need to change. And that's a huge problem. And what about this kind of automatic optimization of the performance? Still, I mean, the same problem, right? So if you have one query, for example, give me all part A supplied by supplier B, right? Give me this query. You have different implementations, right? You can find all the part, because you can pick different starting point in the network. You can start from all the part, try to find all the supplier, or you can try to go to some supplier, try to find all the part, right? So you can pick all those different starting points, have different paths you can do to traverse this network. And different of those different ways of implementing this query have different performance. If you are a user using a database system, it's your job in the network model to consider all of this. And that's something we don't really want. Okay? So just to recap, the network model is great improvement over hierarchical model, right? So I still have a whole bunch of these problems. So, but again, there are applications that all of these problems are not problem. And that is why you still see this type of thing still being used in practice. But the natural question to ask is, can we do even better? How should we think about our query language? How should we think about our data such that I can get that 4 great properties that we really want? And that goes to the relational model, which is actually something that we are going to be focusing on for this semester. Relational model started in 1969. That's when the first paper got published, right? So it's one of the most popular way for to think about data today, what we are going to focus in this course. If you look at all those different database systems, they are actually taking a relational view. So again, let's think about how does it work, what are the advantages, and what are limitations. So the data model of relational model look very different compared with hierarchical model and the network model. So essentially, I think about my data as a whole bunch of relations. And each relation is a set of tuples of similar type. Okay? Up to here, it's very similar to the record type in hierarchical model and network model, right? So, but I do not have those connections between my record types or relations. Instead of having something look like this, in a relational model, you have these 3 different relations. You have supplier, supply, and part. They do not form a hierarchy. They do not form a network. They are just 3 sets of tuples. And a database instance, right? So if you look at a relation, right, it contains a set of tuples, right? For example, if you look at the supplier relation, right? So one potential tuple could be this ABB tuple, right? You can have other tuples. So a database is a set of relation. Each relation has a set of tuples. You can think about this as organizing your data as a whole bunch of tables. Okay? Each relation becomes a table. The supplier relation is a table look like this, right? And you have the supply, have part. All your data organized into tables. So that's a data model of relational model. As you can see, right, it's actually kind of different from hierarchical model and the network model. I do not want to model the connection between all those relations. My database is kind of just have a set of relations. Each one of them has a set of instances. It's kind of much simpler about how we think about data. And the query language is also very different. So instead of doing a record at a time, I write my query as set operations. Because now my data is nothing more than a set of tuples. Each of the relations is a set. In the mathematical sense, it's a set. I can write my query as a logical formula about how to manipulate those sets. For example, if you want to say, yeah, give me all the suppliers for part A. Remember in the hierarchical model, I need to say, yeah, this is how your data are connected. You find the first supplier, go through all the parts connected to that supplier, and then return that to me. Instead of doing that, because my data are just sets, I can write set operations over those relations to give me those answers. This is just one way to write in a really theoretical way, right? So about this query. What do we want? I want a pair, R and P, that satisfy the following condition, right? My R is going to be a tuple in the supply side. My P going to be a tuple in the part side. And then some condition need to satisfy to make sure they matches. And that is how you write a query in a relational model. Instead of doing those record at a time, tell data how to traverse this network, my query become a set operation. So later on, we are going to learn how to write that in a kind of human understandable way, right? How to write a SQL query to specify pretty much the same thing. Okay? But the point is, when you organize your data as a set of tuples, you can actually write those type of set at a time. I don't do record at a time. My query is this logical formula, manipulate my mathematical sets. And you can write the second query in similar ways. It's simply a longer formula, right, to specify the condition that some tuple is in the result. I don't tell the database how to find those tuples. I tell the database the condition, and it's a database job to really understand how to find the tuples that satisfy this condition. Again, in practice, in a couple of weeks, you are able to write a SQL query look like this, which specify pretty much the same logical formula. If you think about why do we like this, right? Let's go to the first property. Let's think about data independence, right? Our query language assumes the relation is a set or bag of examples. I don't know how they are stored. I don't know what is the first tuple in this relation. I don't know what is the second tuple in this relation. All I know, there are a set of tuples being stored in some way on my disk. In the query language, I do not use how they are stored, right? So that's actually move one level ahead in terms of data independence, compared with network model, compared with hierarchical model. And if your physical data representation changes, for example, you have a relation, you shuffle your data, right? So you do not need to change your query because your query have no idea how the data are being stored, right? So that is actually something we really like about the relational model. It's kind of introduce this notion of data independence. The query is a mathematical formula, specify the condition. And no matter how your data are being stored physically, as long as it has the same logical schema, your query will not need to change. And the second thing is about this kind of declarative performance optimization thing. And that's actually something that we really like in relational model, because if you compare with a query you are going to write in hierarchical model, one thing you are going to realize is in relational model, I don't really tell you how to get there. I just say, okay, so my result is it's a pair of two tuples that satisfy this condition. I don't tell you you should go to find a part, or you should get to find a supplier, you do this, you do that. I don't tell that to you, right? So I tell you what I want, and database is going to figure out how to get there, right? So that's actually going to give you this declarative performance optimization thing. As a user, right, you don't worry about performance. Actually, you have no way to worry about performance, right? So you don't worry about it. It's a system try to optimize that for you. So this is a relational model. This is actually three very popular data models, a different type of data system that people have in the last half a century. So it wasn't clear, and right now, right? So after 50 years, we stand here and say, yeah, relational model looks really good, right? It makes sense, right? But actually it wasn't clear back in the 70s which one is better. Is relational model better, or is the network model better? So there's a huge debate in Sigmund 1974 about these two different types of data models. So on the relational model side, there are a lot of people like that, okay? For a whole bunch of reasons, right? And then on the network model side, there are also a whole bunch of people like that. Yeah. So one of the arguments for the network model is in the relational model, you are assuming the system can optimize the performance automatically, and people will imagine that's super hard to do. People used to have this view that performance optimization need to be done by human, right? So there's no way the system can do that automatically. And that is why when you write a query, you should tell the database, this is a good way to run this query and get me this answer. So as you are going to see, there's a huge amount of research in relational model goes into this. And today, when you have relational database, sometimes as a user, you still need to worry a little bit about performance, but most of the time, the query optimizer that automatically search for the best imitation is actually not that bad. And because of that, so I think relational model is actually today in many applications, it's actually much easier to use than the network model. And both sides actually start to improve over time. You start to see some of the ideas start to converge, right? So in network model, you start to have this declarative optimization. In relational model, you start to have something good about network model being implemented there, right? Both sides improve over time. But at the end of the day, I think it's fair to say the market pick the relational model as the, not dominating, but as being a popular type of database systems. So just to recap, right, we see these three different types of data models, right? And we see the importance of data independence and declarative performance optimization, right? So designing data model and query language are actually not that trivial, and that's something we are going to look at in this course. So what's next, right? What happened next? So if you look at today, the landscape, hierarchical model actually doesn't go extinct, right? So you are still triggering a whole bunch of transactions in hierarchical model every single day. Actually, maybe much more than relational model, to be honest, if you measure the number of transactions you are triggering. The network model also doesn't go extinct. It's actually get a new life in XML and JSON. If you look at these two different applications, you will see how similar they are, not to a relational model, but actually to the network model, where your data is a network, right? So it's still being used a lot. And database system today is a huge industry with many exciting opportunities. People play with different data models. For every single of those data model, you have a different type of database system that you can play with. People start to enrich the query language, right? Put in analytics, put in machine learning to enrich what you can ask the database to do for you. And you have database with a whole bunch of new technologies, modern hardware, LPGA, those huge memory machine, right? All the machine learning thing, right? So in this course, we are going to take one point in the space to go deep. That is, we are going to focus on relational model, and we are going to focus on the traditional architecture of such a system. So this is the first lecture. It's a really high level. The goal is for you to understand why do we need a database and how to link the property we want to some real-world applications. Starting Friday, we are going to go deep on the technical side. We are going to talk about query language and relational model. OK, so that's all for today. Thank you, everyone, for the attention, and I'll see you guys on Friday. Yeah.